Hi, I'm Jignesh Shah, Senior Technologist from Samtec. And today I'm here at the Keysight booth with Mike Resso at DesignCon 2022. Mike, why don't you say something about yourself?
Thank you, Jignesh. My name is Mike Resso. I'm a signal integrity application scientist in the Internet Infrastructure Group at Keysight Technologies.
And Mike, thank you for your time. I have a few questions for you. What will be the technical challenges that the designers of the next generation systems for 224 gig face?
Good question, Jignesh. 224 gigabit per second is such a blindingly fast speed that the new pulse amplitude modulation 4 will need to be used. So instead of the non-return to zero eye diagram with one eye, this actually will have three eyes using PAM4. Not to mention all of the signal reflections, insertion loss, and jitter conditions that'll cause poor signal integrity at these higher speeds.
What type of design tools will be needed to characterize and validate these 224 gig channels?
Yeah, it's going to be more important now than ever to do both time domain and frequency domain measurements. So rather than just staying in one domain, looking at time domain reflectometry or vector network analysis, we will need to look at both. And also simulation will be very important in conjunction with measurements to try and correlate the two, and that'll give you the best designs possible.
Okay. Speaking of test equipment, what new technologies is Keysight demonstrating at DesignCon this year?
Yeah, matter of fact, we have a brand new BERT, a bit error rate tester, and this is actually the fastest pattern generator inside this BERT in the world today. So it's going up to 224 gigabits per second. And if you wanted to, you could get more information at the website keysight.com/find/M8050A.
Nice. And you talked about it earlier, so what is more important at 224 gig? Is it simulation or is it measurement?
Well, they're really both important now. You know, before you have a prototype built, you do need to simulate to predict some of the problems that will come up. Then when you finally build your prototype, you can go ahead and make your vector network analyzer measurements, look at S parameters, do the inverse fast Fourier transform, look at time domain, and then compare those measurements to the original simulation. And it's once you achieve the correlation between those two that you'll be able to get the fastest channel possible.
Nice. And Mike, what are we seeing here today?
What we have here is a 16-port vector network analyzer, and we're looking at S parameters being measured from this Samtec NovaRay mezzanine connector, and we're able to look at all 16 ports simultaneously, both return loss and insertion loss, and then we're doing post-measurement analysis with physical layer test system software. So this is really the first scalable vector network analyzer in the world.
Lastly, Mike, what resources can you point our viewers towards who will be designing the next generation 224 gig physical layer systems?
You know, Keysight prides itself on being an educational industrial company, so a lot of the things we do at DesignCon and other conferences are to trying to educate not only the neophyte engineers, but also some of the advanced engineering techniques. And so if you want to go to our technical library for signal integrity, you can go to keysight.com/find/PLTS, which stands for Physical Layer Test System. And also maybe I can take the opportunity to plug my signal integrity book.
Oh, absolutely.
Yeah, so this is signal integrity characterization techniques, and you can get your own soft copy for free at keysight.com/find/Resso book. That's RESSOBOOK for free.
Thank you so much for your time today, Mike. Do you have any questions for me?
Yeah, I mean, we've got your NovaRay device under test here. That we've looked at S parameters and time and frequency domain, but maybe you can tell us more specifics about this mezzanine connector.
Oh, thank you. So the NovaRay is Samtec's highest rated 112 gig connector system. In fact, it has enough bandwidth to go well beyond it to 224 gigs. The reason it performs and has such a high bandwidth is because of its unique construction of being a BGA style connector coupled with a guaranteed 2 points of contacts for the dedicated differential pair. And it has shielded grounding all the way around these differential pairs. And that's what gets it all the way to 224 gig performance. And when it's on the chip package, that is what is needed for 224 gigs. And so for more information about the Novaray, please go to samtec.com/112. Thank you.
Very good. So I'm assuming that the grounding you have inside the mezzanine connector is what helps keep the crosstalk so low.
That is correct. That is correct. That's a good point. So the differential pairs that are grounded, shielded grounded, keeps the TX to RX and also just the NEX and the FX very low, all the way up to 56 gigahertz.
Very good. Excellent. Well done.
Thank you.